So are you able to see the screen?
Yes.
So then we'll start with the introduction
Okay.
to quantitative analysis. So purpose of on what we said yesterday is that quantitative analysis so this is the QA section. We say it's a scientific approach used by management in terms of decision making. So you can write that it's a scientific approach used by what?
Management.
Management for decision making.
Okay.
For decision making. Let me admit somebody here.
Okay.
So you can see,
I am just seeing what we wrote yesterday.
Oh, I haven't shared this.
You have not shared yet, Leo.
Okay. So Steve, welcome to our session.
Thank you.
Yes, sir. So we then this is now the definition of that quantitative analysis.
Okay.
So this one, then you can indicate here, it involves use of tools and techniques. It involves use of tools and what? Techniques for preparing reports, etc. Okay?
Yeah.
Then now right here, advantages of quantitative techniques, QA. Because sometimes you will be asked those questions in an exam. Like I've seen there's a past paper. This is 20, let me check. This is 2022. There was a question on advantages of QA. So you can write is one, it's used for logic, mathematics, mathematical logic. Let me admit somebody here again.
Okay.
So here we say used for mathematics, logic, and precise. That's one. Roman 2, it adopts what you call optimization. Optimization. So here we deal with the issue of cost optimization. So we are going to do what you call linear programming. Linear programming.
Yeah.
It's a very important question you can't miss in an exam. Then lastly, the other advantage of QA or quantitative analysis, it eliminates what you call guesswork. Eliminates guesswork. How? It eliminates guesswork in making decision. How does it eliminate guesswork here? Because every decision we are going to make, it is based on. Think. Let me unmute. Good. So what we are saying is that for every decision we are going to make, we use framework or what we call techniques like linear programming for cost optimization. We are going to use Markov analysis for predictions. We are going to use matrices for decision what? Making. Very good. For decision making. Somebody saying, yeah, I know it's free and new, but there's no better pen or word. Steve, you can't see that? Okay. So that aspect of decision making. Then we will have here the disadvantages of that. Cpa Quantitative analysis. So unfortunately, we don't have the disadvantages. So
Yes.
So here we don't expect to have this because you can't come up with a model, then you expect to have disadvantages unless you critique on the advantages. Unless you critique on the advantages on that model, on the model. So then the basic terms used on quantitative. So just indicate here terms used in QA, the basic terms. One of them is variable there. Okay. So these variables, they are subject to what? To a model. Huh? So this is subject to a model. Subject to a model. So here according to your level, we will look at the variables here, A and B, where we have the independent what?
Variable.
Independent variable. And also we have
dependent variable.
Yes. So those are the common variables we will deal with them in this perspective here. So maybe we can define here. We start with the definition of independent what?
Variable.
Independent variable is always X. Sometimes it's called a predictor variable. A predictor what? Variable there. So a good example we can give is let's talk about cells and growth. Huh? Cells versus growth. Okay. So growth depends on what?
Cells.
So cells predict growth. So our cells becomes X. Why? Growth, like that. Let me admit somebody here. Like that. Then so you will have here, so I want you to just indicate here, under independent variable is always x, which is the predictor variable. Okay? Which is the predictor variable here. Which is the predictor variable. Then we move to dependent variable. Dependent variable. Yes, Steve.
Okay. So sorry to interrupt, but I have a question.
Yes.
Can we, in some instance, have sales as the dependent variable?
Yes. It
Whereby
depends.
we have some factors that will either lead to the increase or decrease in sales.
Very good. So it depends. That's a good observation, Steve. Sometimes cells can become the y-axis. You know, like we say cells, what leads to increase in sales. For example, if you have advertising, let me bring in the aspect of advertising and what versus sales. So what predict the other?
Advertising predicts sales.
So advertising becomes X, Y changes to, sales changes to what?
Y.
Yeah. So so we will come there. Those are perspectives you can get. So always we don't want to cram this. You only need to get a concept that when you're given a question, what predict the other? That is where now we can have those variables interchanging. They keep on interchanging. Let me add somebody here. Is there really somebody? Okay. So and then we move to, of course, we move to dependent variable now. What we call to independent variable. Dependent variable, which we have said is always the what we call the y is our independent variable. So dependent variable is y. Okay, is y. It changes due to change in the dependent variable. Sorry, it changes. This is, you can say, changes due to change in independent variable. Independent variable. So you can be given a question like, say, y is equal to x1, x2, x3. And then somebody can also give you another question, y, a model like y is equal to x plus, let's say, x plus what? Plus c, like that. So those are two models. What's the difference between the two models there? Is there a difference between the two models?
If I can give it a trial, is that in the second example, the predictors are two different parameters, but in the first one, they are the same parameters, but maybe in different ranges.
Different ranges, huh?
Yeah, or amount.
Yes. So what here we are going to get two models. Model 1, this is what we call a multiple regression model. a multiple regression model, meaning we have more than one dependent variables. More than one dependent variables. Then this one becomes what? A simple regression model. So under QA, you get questions. Questions will be asked is on multiple regression model. So, and this multiple regression model, we are going to use a simplest way to do it. You can do it direct from your calculator. Just use a calculator, input x1, x2, x3 like that. Say that now you can get the variables for x from this equation. So what it means, if I can illustrate further, model 1, the y-axis is affected. Is the contribution of y can be made from more than one dependent variable. We are saying, for example, here we are saying, let me use the other one. We are saying that sales depends on what? On advertising. Okay. So advertising predicts sales. So this is X, this is Y. But we are saying, is it only advertising which predicts sales? Is there any other factor apart from advertising?
Yes.
Yes, like here. So we are saying advertising.
Pricing.
Pricing. X4, X3 can be talk
branding.
about, okay, branding or reputation, all those. So we are saying the contribution of sales is from X1, X2, X3. That's how. But if you go to higher levels, if you are going to do your PhD and master somewhere, or yes, we are saying you cannot list all the factors, all of them. We bring in what we call the error term. Error term. That is a symbol for an error term. An error term means there are other factors which are not explained by the model. So you indicate here the error term. So, but your level just know up to, we don't have the error term. We don't have those aspects. Okay. Then now we move to types of we have another term, what we call is a function. A function. The second term is a function. A function. So functions, or a function, is a phenomenon. We'll talk about is a phenomenon which predicts the future state. Like that. Types. So we can have here types of functions. One is polynomial function. How does a polyo means many? Okay, meaning like the question here was forming this one. If we raise this to power, let's say power 2, power 3, like that, this becomes a polynomial function. So a polynomial function looks like this, where we say y is equals to, for example, a plus p1 x1. Okay, that x1 here, Roman 1, power 1, b2 x2, b3 x3, power 3, like that. Then we have, meaning we can have as many as possible. Then we have the end. End root will be Pn x raised by n, like that. That's a polynomial function. A polynomial function. And you know what is y, what is x. We have already explained what is y and what is x. Now, what are the types of those polynomial functions? Types. We want to illustrate from here. We want to see what is this are we calling a polynomial function. So, for example, the first degree. This is what we call a degree. This one. Let me say a first degree. First degree polynomial, which is in this case here is this one, the x1. You know, the x1. That is the first degree polynomial function. This one. So you can get here the x1. Okay, the x1. The x1. Then the second degree polynomial function is x2. Third degree polynomial function is this one, the x3, like that. So the cubic here is the third. The square here is the second. Then the 1 raised by power 1, it becomes the first degree polynomial function. Polynomial function. Okay. Now, we also have what we call multivariate function. The multivariate function, so you can indicate here number 2, multivariate function. Multivariate function. Multi means many. So it is a function that has more than what? One independent variable or a predictor. Okay. So it's a function like this one here is a multivariate function. This one you can see. This is a multivariate function because we have more than one independent function. So it's a function having more than one independent. You can say a function having more than one independent variable. One independent variable. For example, e.g., y is equals to 10x plus 3m. So you can see our x here is a variable and m is another variable which is totally different from x. Which is totally different from x. So it's a multivariate function. It's a multivariate function. It's a multivariate function. It's a multivariate function. The second one, bi. There is what you call bi. Bi means two. Bivariate function. Bivariate. Bivariate function. So bivariate function is a function that has two independent variables. Two independent variables. Two independent variables. Roman 3, another function is what we call U, univariate. Un means one. Univariate function. Univariate function. Then we write is a function with one independent variable. So one independent variable. One independent variable. This one we said it has two. Remember that. Two independent variable. Two independent variable. Two independent what? Variable. two independent variable. Good. Then the other one is what we call exponential. Exponential function is very, very important in QA. Last time when I was marking this paper, there was an exponential function, of course, on the preliminary questions for exam. So exponential function is where an independent variable has a power, as a power. The independent you can get here is where the independent variable has a power, e.g. power a. So you can say y is equals to a raised by, let me use which one? Let me use a different here. Let me say raised by x. So x is an exponential function. Or you can be given y is equals to a raised by n. A raised by n. So that becomes an exponential function. An exponential function becomes an exponential function. There are so many functions, so I will invite you go and look at other functions. So the other functions I invite you to look at are the following. The other functions I invite you to look at are the following. One, just go look at what we call the discrete function. Discrete function. So you can look at the discrete function. Discrete function. Look at what we call implicit function. And also look at what we call explicit function. Explicit function. Those are other functions which you can look at. Okay? Functions which you can look at. Other functions which you can look at. Now, can you look at the applications? So we go to applications of polynomial functions. Applications of polynomial function. Application of polynomial function. Polynomial function. So one, we can apply in form of linear function. Linear function. For example, we say y is equals to what? A plus bx. That's what we know. That's a linear function. So given the following points is, let's say example, given the following points, so we have point here, that is 0.127, the other one is 712. So can you form a linear function from here? Can you form a linear function? Yes. So here, just say develop a linear function. Develop a linear function. We are building the foundation so that now when we do matrices, 2 by 2 matrices, you can solve either using the linear function. When you go to Markov analysis, the same. So are you able to do that?
Yes.
Uh-huh. So,
In terms of explaining, or
you are given the points here. Point A.
2.7 and point B 7.12.
No, it's the same. It's the same, eh? So this is B, eh?
Okay.
Yes. So I want you to form a linear function.
So I think this is where we have a graph of y and x, where y is the vertical axis and x is the horizontal axis.
Yes.
So we can take the first representation to be x, and the second representation to be y, so that 2.7.
So you are saying here, this is x, this is y.
Yeah, and in B, x and y.
So
Yeah.
then you come and say y is equals to a plus bx.
Yeah, exactly.
So I put here 7 is equals to a plus 2x.
X. Yeah.
Okay?
Yes.
Sorry, not 2x, but 2b.
2b, yes.
This
is
is
like the linear function of y is equals to mx plus c.
Very good.
Yeah.
Then here you bring 12 is equals to a plus 7b.
B. Yes.
Then now you solve this equation simultaneously. Yeah?
Yeah.
Okay.
Yeah.
So how do you solve this? You find the value of a.
Okay.
So you can either subtract. Okay.
Yeah.
So you can say here to subtract. Say that if you subtract -7 minus 12 becomes -5.
5.
-5 is equals to a minus a is 0.
0.
Plus, this is 2 minus 7 negative 5 b.
B.
So that now you remain here with the -5 is equals to -5
b.
Divide by -5 by -5.
Get B is
cancel.
1.
So B is what?
1.
1. Now you come and say you need to solve what?
For y.
Not for y, but for a.
For a, yeah.
Okay?
Yeah.
You need a now. So you come here, you say you can come up with one equation. Like say you take equation 1. Okay? Are you together?
Yes.
So you take equation 1 and say 7 is equals to a plus 2b. But
we have b.
B is equals to what? 1. So then 7 is equals to a plus 2 into 1. So 7 is equals to a plus 2. So 7 minus 2 is equals to a. A is equals to
5.
So then you can form our equation and say our equation, the model of the equation in which you can use to predict, you can say y is equals to, what is a? Is 5. Plus bx, what is b? Is 1. So which is the same as what? X.
Yes.
So that is what we can have. That is a linear what? Function. What about this one? Assume you are given like this. You are given this here. Another point C, you have here 510. You have 1020. So you are told to form a linear or a model, develop a linear function. A linear function. Develop a linear function. Develop a linear function.
We'll do the same method.
Yes, can you try?
Okay. 5 can be x and 10 to be y. In the first case,
So
and
this is x, y, x,
and
y.
x, y.
Yes.
So y is equals to a plus bx.
Mm-hmm.
Yeah, you can write so that I try to follow.
Okay. So you have said we have here x was 5, y was 10. Was it 10?
Yeah.
Yes. Then we add here x, y. So this is 20, sorry, 10, 20. Okay.
Yeah.
So now you form an equation and say y is equals to b x plus c.
Yes.
My c, I've introduced another one, which is a. So hope I'm not confusing you. I'm saying it's the same as y is equals to a plus b x. Or y is equals to mx plus c. So it's the same thing. The same thing here.
So
And by the way, do you know that when you talk about like total cost, is fixed cost plus variable cost. Our total cost is what? Is y. Fixed cost remains constant, becomes c, becomes a, becomes c. Variable cost in this case is what?
bx.
Is bx. Very good. So in case you are given, you can be given like application for quantitative analysis. We normally test business models. Business models, like we say, what? Sorry, this is total cost, not total revenue. Like we say, how do we predict the cost? Prediction of a total cost depends on variable cost and fixed what? Cost. So and then you can use the same method, whatever we have done here, to come up with that equation.
2 equations.
Yes, you come up with the equations, you solve it simultaneously. Are we together? Yes. Now, what is the application of this business application of this linear function in business? That's the most important thing. So just write here Roman 2, application of functions in business. Application of linear function in business. Application of linear function in business. One, we use this most important in what you call cost volume profit analysis. Number one is cost volume profit what? Analysis. It's called the CVP analysis. What is a cost volume profit analysis? What is a cost volume profit analysis? So this is we call it, it's a technique, or is a profit planning technique. Okay, profit planning technique. Profit planning technique. So what are we comparing? In this technique, in manufacturing firms, they compare the cost, the profit, and the volume and profit in terms of making decisions. Say that you hear people say, my sales for this month did not break even. There is another concept I will bring in, what you call the break even. Break even.
Point.
Actually, it's called a break even point. Okay, just a minute, I pick a call here. Hey, Mongwan. Yeah. Diani krasinde. Elie Emmanuel. Ngali je. Tiganko olewe krasi. Ngwa kile tokambe. Sorry. So a break-even point is a point at which we will take it.
It's a point where total cost is equals to total revenue.
Very good. So break-even point is a point at which total revenue is equals to total cost. So or what are we saying? Profit is equals to zero. Profit equals to 0. Okay. Profit is equals to what? To 0. So you can't miss, if you go to an exam, actually, they are those what we call low hanging fruits. Kasi nebo wanakuonea huruma, wanasema hatutaki mwanafunzi atoke bure. They bring in the issue of theory questions, like assumptions of CVP analysis. Assumptions of CVP analysis. So there are those assumptions you can pick from the model, like saying, here, it forms what you call linear. It's a linear function, of course, linear function. So one here you say linearity function, which is the same as y is equals to a plus what? Bx. 2, this model or the CVP analysis or parameters are known in advance. So parameters are known in advance, or parameters are known in advance. 3, variable cost depends on what? On quantity. Are you together? Yeah. The variable cost depends on quantity. So the moment you increase your quantity, the variable cost also goes up. Okay. What about okay, again we say here, number 4, the model, the CVP analysis, or what you call here the CVP analysis, fixed cost remains constant. So from the model, you can't miss these 4 of them. Assumptions. Just pick from the model. Fixed cost remains constant. Variable cost depends on volume or on quantity. And also an assumption of linear functions. Now, what is the CVP? Then we are building this model because we want to apply. There is what we call the CVP function or functions. One is the revenue function. revenue function. So you can put here into bracket R. The revenue function. So the revenue function here is the same as saying total revenue is equals to what?
Total cost.
We are
No,
forming
total
a revenue
revenue is
function.
equals to sales.
Sales is now is what?
Why?
So you are
No,
saying, okay, let me write what you are saying, then I will explain later. Sales times selling price, okay?
yeah.
So your sales here is quantity. Are we together? Sales is quantity. How much in terms of volume, number of units you sold that period.
Yeah.
So we can form an equation and say total revenue is equals to Q times
P.
Times P. P is the selling price per
unit.
Per unit. So you can say here where Q is the quantity, P is the
selling price
per
unit.
Per unit. So that's Roman 1. Roman 2 is the total cost function. Total cost function. So the total cost function, we say total cost is equals to
quantity times price.
Total cost. So total cost here will be fixed cost plus
variable cost.
Variable cost. Okay? Into bracket Q. I will tell you what Q means here. So fixed cost remains constant. Variable cost changes. Okay? So Q is the number of units. It's the number of units. It's the number of units. It's the number of units. So you can indicate here where, just write here where total cost, where TC is the total cost, fixed cost, FC is the fixed cost, and VC is what? Variable cost. Variable cost per unit. Roman 3 is the profit function. We want to form a profit function. Then now we combine a profit function. So profit function here, Roman 3. Function. So how do you get profit? Profit is equals to
total revenue minus total cost.
Very good. Total revenue minus total cost. So profit, we use this. This is the abbreviation for profit, which is total revenue minus total cost. Okay. So profit is equals to, you remember what is our total revenue? Total revenue we said is PQ from total revenue function. Very good. Minus TC, total cost we say fixed cost plus variable cost times quantity. Remember that. Don't forget variable cost times quantity, because variable cost depends on quantity. So then you can come and say here, we want to make we want to combine this and come up with a better equation, which we can say again. What is common here? Q. So I can open the bracket and say profit is equals to PQ minus FC. This negative becomes here minus VQ. So profit is equals to PQ minus VQ minus FC. Okay? Minus FC. Then what's common here? Profit is equals to, which is common here?
Q.
Q outside into P minus V minus F C. Okay? What else? Is that all?
Yeah.
Okay. Now, we know this. What is P? P is the selling price per unit.
Yeah.
What is V?
Variable cost.
Per unit. So,
Yeah.
P minus V is what you call the contribution
Margin.
Contribution margin. CM. Okay? So then I can come and replace here and say my profit is the same as QCM minus fixed cost. So this is our final equation we are going to use. Are you together?
Repeat one last time. Hapo kwa contribution margin. That's a nice reminder.
So here we are saying we know that selling price minus variable cost per unit gives us the contribution margin. It's like the profit per unit. Contribution margin means the profit per unit.
Sure. Okay. Well understood.
Sasawa. So if you have the profit per unit, how many units did you sell? I sold 1,000. So you multiply by Q. So Q is the quantity times the contribution margin per unit minus fixed cost gives you the profit. Are we together?
Yes.
Good. Roman 4. Is that the second? Yes, Roman 4. Break-even function. Break-even function or a break-even point. Break-even what?
Point.
Break-even point. Break-even point. I don't know whether you can see that. My screen, I've shared something. Another tab. So the break-even point is a point at which total revenue is equals total cost. So you can write here and say break-even point is equals to total revenue minus total what? Cost. Okay? Like that. Or profit is equal to zero. Now, we know this. If we are saying, we know that the profit of a normal equation is equals to QCM minus what? FC. Okay? Are you together?
Yeah.
So from this equation, you can be asked to get the what you call the quantity. Okay? How do you get quantity from here? Quantity is the same as what? Because remember here, we are going to equate profit to zero. So I put here 0. Let me, what we are saying, at a break-even point, profit is equals to 0. That's what we are saying. So number one, you can be asked to get the break-even point in what? In units. Break-even point in units. Okay? So if you ask to get the break-even point in units, and then you come and say, you know that profit is equals to QCM minus fixed cost. Then I put my 0 here because break-even point is a point at which profit is equal to 0. So they want me to get Q because they are asking break-even point in units, which is Q here. So what can I do? I come and say I put here 0 because profit at a break-even point, profit is equal to 0, is equals to Q Cm minus fixed cost. So I want Q.
The fixed cost of contribution margin.
Very good. Very good. So this one goes the other side here. This negative comes the other side. If I bring this one here, are you seeing that? Niitoe kwa negative niilete positive. So this is FC is equals to Q Cm. Nahitaji Q divided by Cm divided by Cm. You cancel that. So my Q is equals to fixed cost divided by what?
Contribution margin.
Contribution margin. Contribution margin. Then what about if we ask the break-even point in what? In shillings. So in shillings here, they are looking at the revenue. So to get the break-even point in shillings, you take the break-even point in what? In quantity, multiply by what? The selling price. The selling price. The selling price. The selling price. So which is the same as, you know, the break-even point in quantity is what? Fixed cost divided by contribution margin times now the selling price, which is what? P. That's how you get the break-even point in shillings. Are we together? Any question up there?
So break-even point in shillings. I'm trying to understand it. Like for example, in our formula, fixed cost of a contribution margin times price, and in the contribution margin is price minus the variable cost
Per unit.
per unit.
Yes.
So this break even in shillings, it will be like the selling price per unit, where when you sell at that price, there is no profit or no loss.
Yes, that's what we call the break-even point. Break-even point is either you are making a loss or profit. You are not making loss, you are not making losses, profits. You are at a break-even point. So what it means, your cost equals to the revenue.
So in essence, it's like the buying price.
In essence, is what you are saying is the same as the buying price. The cost you incurred is the same as what you are what you are getting as returns.
Okay.
Yeah. Okay. And B, you can apply this. Contribution margin revenue or contribution margin ratio. Contribution margin ratio plus variable cost ratio is equals to 1. Contribution margin ratio plus variable cost ratio is equals to 1. Is equals to 1. Illustration. You can apply illustration. Illustration 1. firm produces and sells a given product. I hope you are writing to save time. A firm produces and sells a product. A firm produces and sells a given product at Kenya shillings. At Kenya shillings. At Kenya shillings 600. At Kenya shillings 600. And the variable contribution ratio is 0.6. And the variable contribution ratio is 0.6. So automatically, what is our contribution margin ratio?
0.4.
Very good, 0.4. Contribution margin ratio there, 0.4. If the fixed cost here, we are given 360,000. Required. 1. What should be the sales revenue? What should be the sales revenue? What should be the sales revenue that generates a profit? What should be the sales revenue that generates a profit of 240,000? That's Roman 1. Roman 2. Determine the break-even point in units and in value. Determine the break-even point in units and in what? And in value. And in value. So we know that profit, the first question you are saying, what should be the sales price? Sorry, what should be the sales revenue that generates a profit of how much?
240.
240. Yes. So how do we do it? So tunatafuta revenue. But we know that profit is equals to profit
Contribution margin minus fixed costs.
Cost. So what are we given?
Profit is given.
Profit is given. Are we given quantity?
Fixed cost is given.
The CM.
Contribution margin ratio is 0.6.
0.4, yeah?
0.4.
Yes. So can you determine Q, quantity? The moment you know quantity, what is the selling price? 600.
Yes.
So you can get the revenue, eh? Are we there?
Yes, selling price and quantity.
So
we find quantity.
Yes.
Okay. Q is it that big? 1.5 million.
Yes. Is it the QMR revenue?
Q.
The question is asking about the sales revenue.
Yes. So what are you getting? What is Q first?
Okay, first I have a question. If the contribution margin ratio is 0.6, so what is the contribution margin and not as a ratio?
So, a ratio, when you talk about a contribution ratio margin, we agreed that when you have the contribution margin ratio plus variable cost ratio, they should add up to what?
1.
Up to 1. Eh?
Okay.
The question gave us the variable contribution ratio of 0.6. So meaning, whatever remains 0.4 becomes what?
Contribution margin ratio.
Yeah.
Ratio.
So the 0.4 contribution margin ratio. So as a contribution margin in itself, so is it still 0.4?
It's 0.4 contribution margin.
So you're saying contribution margin is the same as contribution margin ratio?
Yeah, that is what I am asking, if it's the
No.
same.
Contribution margin is equals to what? Price minus variable cost per unit.
Okay.
So contribution margin ratio is like you are saying this price divided by the variable cost. Okay? Or if you talk about variable contribution what? Ratio is the same as, again, variable contribution ratio is the same as V divided by the price. I don't know whether you are getting that. The interchange. So this one, the variable contribution margin is not the same as the variable contribution ratio. Upon a ratio meaning you have divided. Margin is the difference.
Okay. So a clarification. So for this equation of equals to 1, the first one, contribution margin ratio, is like the price per unit.
Per unit, very good.
Yeah, and the other one is cost per unit.
Yes. Price per unit, cost per unit. Kila kitu ni per unit, please remember that. This is called contribution margin per unit. So when you do that, let me again share here. We do it together. What are you getting as quantity first? Now, I don't know whether you can see that.
Yes.
Remember we said when profit is equals to what? 0, eh? Profit is equal to 0, which is we are saying is the break-even point where we say it's a fixed cost divided by fixed cost divided by what? Divided by contribution margin. But the question is saying we want to determine the targeted revenue. Okay? So the targeted revenue, which is R, you can get it by getting the fixed cost, this fixed cost here, plus the profit, because remember this is now 0, that profit divided by contribution margin. Ukiuliza targeted revenue, you can use that equation again. The targeted revenue, where you are given the contribution ratio here, contribution ratio. So and then the revenue is equals to fixed cost was how much?
360,000.
360,000.
Yes.
My profit was 240. Contribution margin ratio ni 0. What? 4.
0.4.
4. So the examiner here, he wanted for you whether, do you know that the contribution margin ratio is the same, is plus variable contribution ratio is equals to 1? Because he only gave you the 0.6 as a variable contribution. So he was testing you the concept of ratio. If you have the CRM ratio plus VCR ratio, it should give you 1. So when you do this, what are you getting here?
600.
600.
600,000 over 0.4.
Gives you
1.5 million.
1.5 million. 1.5 million as your revenue. So how? Roman 2, break-even point in what?
In units and
Units.
in value.
So break-even point in units is equals to fixed cost. Fixed cost divided by what? Contribution margin. Contribution margin. So this is the same as, remember contribution margin is the selling price minus variable cost. Right together. So meaning if you have the selling price.
Yeah.
Okay. So this is the same as saying here, fixed cost in 200 and what? Is it 200 or 300? It is 360. Divided by what? 0.4. So you get what? Is it 90,000 or 900?
900,000.
900,000 units. That is in terms of units, huh? That's in terms of units. Then the last one was asking break-even point in
value.
In value or in revenue. So break-even point in value, you get the break-even point in units times what? Selling price. So in value, I know the break-even point in units is 900,000. What was our selling price?
600.
600, eh?
Yes.
So unapata ngapi? What do you get?
Is it the 3 million, that million? Let me check. 540 million.
540, yeah?
Yes.
Break-even point in value. Okay. So if you go to, I don't know whether I will share with those who are ready to join us for past papers. There's questions on May 2023. Can also see you have December here, 24. I think this is question 4. B. Question 3. Stay there. On the break-even point scenario. So,
Yeah.
good. Now we move to another concept. Application number 2, determination of market equilibrium. Of market equilibrium. Determination of market equilibrium. So market equilibrium. How do we ascertain equilibrium? So a point at which this is Y, is it? This is which function is this?
Linear.
No, which curve is this? The one that slopes from right to left. All right, tuanze na hii. Supply or demand?
Okay. Supply. Okay. The X is demand.
Not the X, eh?
Okay. I'm trying to. Okay. The one that comes from bottom to up is the demand one.
No, okay. Demand is from left to right.
Yes, I said bottom. Yeah, that is similar.
So demand slopes from
left to right. I mean from the bottom.
Is this right to left.
Demand comes from up to down.
Okay, I want you to use the words like right to left, left to right.
Left. Okay, upward is the demand.
Now, I want you to look at this graph. Where is your right hand side? So, demand curve slopes from right to left. Sasawa. Supply SS slopes from left to right. Are we together? Are we there? I think I've interchanged. This is left,
It's confusing.
left to right. Hapa. Weka mkono yako mahali iko. Yangu sahihi uko mahali unasema top ya D uko hii. Assume hapa ni 1, hapa ni 2. Number 1 yangu mkono yangu ya left iko on 1. Are you together?
Yes.
Number 2 iko kwa right. Tuko sawa?
Yeah. Yeah.
Sawa. Sasa ukikuja the one for which one? For supply slopes from right to left. Now you interchange. Right to left. Now, when you have here these dotted lines, this is quantity, this is
Price.
price. So my equilibrium is a point at which S does what?
Is equals to D.
Good. Is equals to D becomes my equilibrium
Point.
So this is Q quantity is equilibrium quantity. Then E price.
Equilibrium price.
So that's what we want to do, because determination of market equilibrium. That's our main concern. Determination of what?
Market equilibrium.
Market equilibrium. Market equilibrium. So allow me to share something here. So a firm, you can write example. A firm produces and sells a product with the following features. Following features. Roman 1, the price of this product here, P is equals to 7,500. So when price is that, quantity is 1,000. Okay. P again, when we have P is 4,000, 625. Quantity is 750. Required. Develop a function. function, and determine supply and demand. Develop a function and determine supply and what? And demand function. So you must know what is the behavior of the demand function. Roman 2. Determine the equilibrium price and the quantity. Determine equilibrium price and quantity. Determine equilibrium what? Price
and quantity.
And the quantity. So Kiona, this one, what comes into your mind when you see those? Which function is a linear?
Linear function.
So you come and say
y is equals to a plus bx.
So sawa.
Yeah.
Where in this equation here I can say where
y is the price.
Very good. Y is the same as what? Price. Which is what? P. Okay.
Yeah.
Then my A is constant. Huh?
Yes. B is the variable.
Then B is the variable which is the gradient.
And X is the quantity.
X is my quantity, which is Q. Don't know whether you have copied this. I want to slide up again. Okay. So if we use this, what we have indicated here, we have agreed Y is P, it's the price. So then I would have price is equals to A plus P Q. Is that true?
Yeah.
Yeah. So form equation 1 and 2, solve simultaneously. We form a model. So then I will come up, I pick P7500 versus what? 1000.
Yeah.
So 7000. Question 1 is 7500 is equals to A plus 1000 what? B. This is question 1. Question 2 there
4625
versus 750.
Yeah.
4625 is equals to A plus 7 what?
750B.
B. So we can subtract.
Yeah.
I can see B will be how much here? So 1000. Remember this is 0. I'm subtracting here. A minus A is 0. 1000 minus what?
750.
You get plus 250.
Yeah.
Is equals to 7500 minus 46.
2875.
2875. So divide by 250 by 250.
11.5.
11.5. Now substitute in the end of the equation to get the value of A. So substitute in equation 1. So and then equation 1 here, I will have 7,500 is equals to, what is A? A is what we are looking for, plus 1,000 multiplied by what? 11.5. So then 7,500 is equals to A plus, what is that? When you multiply 1,000 multiplied by that,
11,500.
11,500. So A, this one will come the other side, you subtract.
Negative 4,000.
Negative
4,000.
4,000. So our equation will be P is equals to, up here, A is what? Negative 4,000 plus B is 11.5 what? Q.
Thanks.
Are you together?
Okay.
Yes. Remember X is what we said here as Q.
Yeah.
Remember here where you said is Q, eh?
Yeah.
Yeah. Now, question 2, remember this question we want to determine, this is a function. Is this a function? We want to determine, is this a demand function or a supply what? Function. So you know the features of a demand function. Demand function, you remember the demand, how do you define demand? We say the demand of a product, when the price goes up, what happens? The demand
Goes down.
So it's the opposite. But for supply, is that it has what you call a positive slope. Okay?
Yeah.
When the price of a product, like during the time of farming, you know, the price of a product, you feel like the price is going up. The supply does what?
Increases.
Increases. So what is this?
So this is
Supply.
Supply function.
Why?
Because it is negative. No, this is the negative one should be the one that is sloping downward. So the demand.
When you define, you use the gradient.
Oh, the
gradient is positive.
Oh, the gradient is positive, so it's a supply function.
Very good. So you come and say this is a supply function because the gradient
is positive.
Oh
yeah, because the gradient is the one that shows the slope of the graph.
Very good. The slope of the graph. That's how. Have you copied that?
Yeah.
Okay. So there's also another one. You can try this during your free time. Illustration 2, where you have here P, price is 25. Quantity is 100. Price number 2, 15.25. 200. So then we can do it very fast. Because of time, I see if I introduce another concept, we may not finish. So I can do this one, then we'll stop there. Where we say, we have agreed this is a linear function. So my price is equals to A plus P what? Q. Okay. So take Question 1 is 25. 25 is equals to A plus what?
We can't see the board.
Oh, I haven't shared. Sorry.
You can't see.
Now that is it. You can see that, huh?
Yes.
So 25, 25. A is what we are looking at. Then 100 what? 100Q. Oh, Q is our, 100B here. Then the other one is 15. 25 is equals to A plus 200 what? B. So you can subtract. This is 0 plus this is negative. 100B. When you do this, comes to how much? Is it 1,000? Is it 1,000?
Yes.
Okay. So this negative here, negative. So this divided by negative 100. Divided by negative 100. You cancel. This remains with positive. B is equals to
Negative 10.
negative 10. So our A, P is equals to A plus PQ. So what is we can now replace here? We can replace the first one, which is 25. 25 is equals to
A
A
plus negative 10. Okay.
negative 10. Very good. You are okay?
Negative 10B. No.
P is this one. Eh?
Yeah, negative 10.
Then 10. What is Q? Is 100. Are you seeing that?
Yeah.
So this is 25. 25 is equals to
A minus 1,000.
1,000. So this is 25. 25
Plus 1,000
plus 1,000
equals to A.
A. This is 35. 35.
35, 25.
35. 25 is equals to A.
Yeah.
So then our equation will be P is equals to A. 35. 25. It requires negative, is it?
Yes.
Minus 10.
10.
10 what?
Q.
10Q. Very good. So you can see our gradient here is negative.
Is negative.
So this is what? A demand
Function.
function.
Okay. I had a question regarding the other example. How do we now determine the equilibrium price and quantity?
The equilibrium price.
Yeah, when we had that function of P is equals negative 4,000 plus 11.5Q, or even with this one.
You know, now let me do the equilibrium price. Huh?
Okay.
So,
yeah.
So the moment this is the demand function. So the equilibrium price, remember we said equilibrium price is a point at which supply
is equals to demand.
So you write equilibrium price is a point at which supply function is equals to demand function. Are you together?
Yeah.
Meandika hiyo?
Yes.
So it's the same as saying equilibrium is equals to DD is equals to SS. Now, what is the demand function? 30. Ndio hii. Are you seeing this?
Yes.
So you bring this 35, 25 minus 10Q is equals to what was our supply? Supply tulikuwa tumepata ilikuwa negative what? Is it negative 4,000?
Yes.
4,000 plus
11.5 Q.
Q. So tafuta Q. Q becomes our equilibrium what? Equilibrium quantity. So then we'll come here. We can bring this one the other side. We add. So 25 plus 4,000 is equals to, that is positive 11.5 Q. Itakuwa plus, sinivo? Then Q. So when you add this is 70 what? 75, 25?
25.
Is equals to 20 what? 21?
0.5 Q.
0.5 Q. So divide by 21.5, 21.5. So what is your Q?
350.
350. Now you can find the price, is it?
Yeah.
You can substitute in any equation, huh?
Yeah.
So and then you come and say you want to get the equilibrium price.
Before you continue,
Yes.
kuna pali nimepotea kidogo. So these two equations are on the same question.
Yeah, same to me actually.
I thought they were different questions.
No, they are the same. You know this, we can only determine the equilibrium price when we have the supply function and the demand function.
Okay.
So I must, the first question I had given is that only I made an error when I said determine the equilibrium price and the quantity. You can't determine equilibrium price and quantity by using one function.
Okay.
You cannot determine the equilibrium price and quantity where you have the price, the supply function
and the demand function. So these two functions are in the same question.
Very good. They are in the same question.
Okay.
That's why we are doing, you can only do the equilibrium price once you have determined the demand function and the supply function.
Okay.
That's the last part. You equate, you say equilibrium price, or you can say equilibrium point is a point at which supply function is equivalent to demand function. Irungu, you had a question?
I think it's the same question as she has asked. So what I wanted to ask, when we got P is equals to negative 4,000 plus 11.5 Q, so how did you, or where did you get that second equation so that you equate?
Which one? The one for negative 4,000?
Yeah. The first one that we got is a positive gradient, so it was a supply function.
Yeah.
Now, in which point did you get the demand function, or in which example?
The demand function, remember, there was, let me share the last part. I don't know if will it allow me. That was it this one? The one for negative what? Negative 4,000?
The first example, I understood everything, how we got the supply function, because we used the price and quantity that you gave us.
Yeah.
But now, where did you get the demand function?
Function from.
Yes.
Oh, so the demand function, remember we had the values. Do you have like 25, the price?
The price.
Yeah.
I think I did not write the
Oh,
I
hiyo
did.
ndio ulisahau.
Uh,
So is this one? Let me share. I think there's something you missed.
or you shared another set of prices and quantity.
Uliona hiyo? Umeona hiyo? Whatever I've projected.
Okay, now I've understood.
This one was P 25, quantity 100, price
Yes.
1525, quantity 200.
Yeah.
That's where now we get the demand function from.
Okay.
Yeah.
Now I'm good.
Okay. So now what is remaining is that we need to, already we have the value of what? The equilibrium quantity is 350, we agree.
Yes.
Now we need to get the equilibrium price. Huh? So
Yes.
substitute any equation, either it's the supply function or the demand what? Function. Yeah. So can you substitute that? So if I substitute here, because of time, 20?
25.
Yes, actually it's 25. It's 25. I think I'll stop there because I have another session.
Yeah, we are learned.
Thank you.
Hi, Asante, welcome. So we're having these classes on, we agreed on what time, Patience?
We had not really agreed because I'd requested next weekend I won't be available.
So it's flexible?
Yeah, so you said it's flexible, so maybe we can get another time. Because we have Friday 6 to 8, so maybe you can get another day evening.
Actually, because you are just behind, I'm willing to add even more time. Huh?
Okay.
Actually, QA before the revision of the new syllabus, it was used to be having a lot.
Okay.
But nowadays, because they changed the syllabus, the issues of revision of the syllabus, now this made it more flexible.
Okay.
Yeah. So then we'll stop there. So Asante, Stephen, you're also doing the same unit?
Yes.
Unafanya QA ama?
No, I'm not doing yet. Only that
Umeingia usome kidogo.
I was thinking of starting the classes.
Oh.
Yes.
Okay. So uliachia wapi wewe?
No, okay. I'm a graduate, but I'd not taken any of the specific courses, the certified courses. So I was thinking of doing the CPA or the data courses. So that's why I was interested in joining the class.
The graduate, you are which area?
Become finance.
Finance. You can get exemption if you prefer for CPA.
Or I can get exemption.
Yeah, they will exempt some units for you.
Okay.
So that now you start on, actually we start on intermediate level.
Okay. I did not know that because I was thinking now I will start at the level 1. I don't know communication, management, accounting, introduction.
Because already those you have already covered.
Oh, yeah,
just
sure.
get an exemption.
Yeah, because even this one we have covered in economics.
This one you get an exemption.
Okay.
So they will get an exemption. You only do auditing and assurance.
Okay.
Company law.
Okay.
You will do, the other one is which one? There's this one, MIS, Management Information System.
Okay.
Financial reporting.
Yes.
Actually, you do 5 units. I think I've said all of them. Company law.
Okay.
Financial reporting.
Yes.
Auditing and assurance.
Yeah.
MIS.
so that I am certified.
No. You
For
finish, that
to
is
finish
now,
intermediate, to finish
intermediate, then now you go to advanced level. Advanced level, there are
level.
six units, yes.
Oh, okay.
Yeah.
Now that is out of the 6. Intermediate has a 6, right?
Intermediate 6, but now they will exempt you. Ufanye hizo 5 of them.
Na ile ya kwanza, the first nini?
Ile foundation itakuwa imetolewa, wameko exempt zote 6 papers.
Yes.
Plus 3.
So I do the 5 so that I finish the intermediate level.
And then you go to advanced.
Okay.
Yeah, advanced, there's no exemption.
Oh, I think that is profound. I will see when to start.
Yeah.
Okay.
So thank you. So Patience, thank you. If you need a record for the same, it is there.
You are to send me inaitwaje?
The notes.
Notes.
Nitakutumia, lakini utasoma kweli?
Kwa nini? Ni ngumu.
Not ngumu. You know kujisomea pia ni shida.
I know kujisomea ni shida, but don't you think
maybe utasoma? But I will share with you the summarized one, because I don't want to share the whole kit.
Okay.
I will share per topic, and also I will share with you the past papers.
So.
Like the past papers, now you can practice questions on determining the group and price. And the other one for CVP analysis. Hizo siko on those past papers.
It's okay, because I was thinking nikikuja hapa kama at least ninajua 1+1, it's easier than kama niko blank.
Yeah, good.
Yeah.
So ndakutumia.
Okay, thank you.
Asante.